Okay, hey y'all. So we are going to do the rational root theorem. Let me get this open. Here we go. I feel like I'm too zoomed in. Okay, so the rational root theorem. This is technically going to be 3.4 for the college algebra class. What it allows us to do is list all of our possible rational zeros. And the only thing I'm talking about is whenever we're dealing with our polynomials and we've been doing synthetic division, if you plug in or divide by, technically, if you divide by a number, then that, and you get 0, then that means that is a 0. So I'm just going to not really do a full example just yet. Basically, if we had f of c and we plugged in our c, let's say it's c equal 2, right? So if we do our division, so we do our synthetic division, and our remainder is 0, then 2 is a 0 of that polynomial. So another thing is, this is where we would have gotten our 2, right? This would be it written in factored form. Technically, doing this, we would know that this is going to be a factor of our polynomial, and depending on what our polynomial is, there's multiple factors. But doing this and using the synthetic division and getting 0 for your remainder, this tells me if I plugged in 2 and I divided and I got 0, then x minus 2, that's a factor. That's technically where this comes from. This is whenever we don't actually know what we're dividing by. This is when we're not told to divide by x minus 2. So we actually divide by is 2. This is literally whenever we just have the polynomial and we need to find the zeros of that polynomial. Okay, so let's just put this. So what we're going to do here is we're going to list all of the possible rational zeros of a polynomial. Okay, so the way that you do that is we're going to take p and we're going to divide it by q, and this is actually going to be plus or minus p. Now, my p is my constant term. My q is my leading coefficient. Okay, so you're actually going to list all the positive and negative values of the factors of your constant term and the factors of your leading coefficient. Then you're going to individually evaluate each of them until you get a list of numbers. Hey, those are all of the ones that have the possibility to be, for the polynomial to be divided by, and for my remainder to equal 0. Now, not all of them are going to give you 0, but this is a list of all of the ones that are possible that can give you 0. So, let me scoot this way. Say we were given, I'm actually going to make that go away. We'll keep that. Say we were given f of x equals x cubed, a negative 2x squared, a negative 25x, and a positive 50. Okay, so now that we have this right here, what we can do is list all of our possible rational zeros. Now, remember I told you we're going to do plus or minus p over q. P is my constant. So my constant is the number 50. Okay, and then my leading coefficient is 1. You don't just write 50 over 1. Okay, what we're going to actually do is you can come over to this side. We need to know the factors of 50. So you would do a little factor tree. 1 times 50, 2 times 25, 3 wouldn't be 1, 4 wouldn't. We have 5 and 10. 6 is not, 7, 8, 9, they also are not. So those are our factors for 50. All of those numbers individually, that's what you list. I usually go in like an ascending order. So I would say it's 1, 2, 5, 10, 25, 50. And then my leading coefficient, that is just a 1. Still not done yet because my P over Q, I'm actually going to consider both the positive and the negative. That's why I have that right there. And so what I'm going to do is actually list these out, taking in consideration that each of them is going to be written as positive and each of them is going to be written as negative. And y'all, there's actually a rule. It's called Descartes Rule. It will make this process a lot easier, but this is something that you do need to know as well, okay? So what we have is a positive 1 over 1, and we have a negative 1 over 1. So that's taking this, and then we're going to take that, and then this one, and then that one, and then that one, and then that one, okay? So scooting over, I have a 2 over 1 and a negative 2 over 1. 10 over 1, negative 10 over 1. 25 over 1, and a negative 25 over 1. I know y'all do see a pattern. Our leading coefficient won't always be 1 though, so you just need to make sure that you always write these out, okay? Okay, so we actually evaluate these. I will get the list of all of my possible rational zeros. So what I get is 1, because 1 over 1 is 1. I get negative 1. I get 2. I get negative 2. I get 10. I get negative 10. See the pattern? Because our leading coefficient was 1, y'all, my possible rational zeros is the positive and negative values of all the factors of 50, because I'm just writing it over 1. If it was, say it was 5, I'd have a fraction. I'd have 1/5. I'd have 2/5. I would have 2. I would have 3. Nope, just kidding. I would have 5. I would have 10. Like, you would actually evaluate those fractions, right? Just like we did here. So this is the list of all of the possible rational zeros. In a problem like this on your online homework, I believe it's like answer the questions A through C, listing all of your possible zeros. This is how you would answer it. You would not write them in the fraction form, okay? So for B, it says to synthetically divide to test and identify an actual zero. So literally, again, this is the longer process and the shortcut I'm going to show you later. But what I would do here is, okay, these are my possible options for zeros. I actually want to know what my real zeros are. So what I'm going to do is I'm just going to start with 1, synthetically divide. Is it a 0? Yes or no? Start with negative, or then move on to negative 2. Synthetically divide. Is it an actual 0 or no? For this particular one, I think we end up getting to 2, and it is a 0, so it's not too painful. This is also why the shortcut exists, because let's say our constant was like 179. Yeah, I'm not trying to go through all of those factors. Do you see what I'm saying? So there are shortcuts, of course. Let's go ahead though. My coefficient, my function, I'm just going to go ahead and rewrite it, y'all. I had an x cubed, a negative 2x squared, a negative 25x, and a positive 50, right? Now I'm going to actually do some synthetic division. My negative 50 is hidden over there. There we go. So I'm going to start with 1. So I know that what I do is I bring down my coefficients, being mindful of my signs. I'm starting with 1. I bring down my 1. 1 times 1 is 1. You write that right here. When you do this right here, -2 plus 1, signs are different, so we would subtract and keep the sign of the larger. 1 times 1 is 1, signs are different, so I get a -1. Those would combine together to give me a -26. -26 times 1 is a -26. Y'all, if I combine these right here, am I getting a 0? No. In all honesty, you don't even need to do that part. What would that be? Signs are different, so we would subtract and we would get a 24. Yes. So we would get 24. So this tells me that 1 is not a 0, which also tells me that x plus 1 is not a factor, right? So ruled that out, move on. I don't want to have to keep going like down and down and down and down. So I'm actually going to erase this. Make sure y'all have that written, okay? Okay, so I am going to do my step again now using -1. I have 1, -2, -25, 50. Bring down my 1. 1 times 1 is 1. Signs are different, so it's negative. Combines to a -3. -3 times a -1 is 3. These signs are different. That would combine to a -22. -22, -1 gives me a positive 22. Also not 0. You could write it again. -1 does not equal a 0. Therefore, x plus 1 does not equal a factor. Okay, so let's do it again. What am I doing? Okay, awesome. The little parts that it kept, I am going to use. I have 1, -2, -25, and a positive 50. Moving down my possible list of rational zeros, I'm at 2. Bring down your 1. 2 times 1 is 2. Signs are the same, so it's positive. 2 combined with a -2. Those are additive inverses, so you would get 0. Then we do 2 times 0 is 0. And then a -25 combined with a 0 is -25. Now we multiply. 25 times 2 is 50. Signs are different, so it's negative. Yes, boom, perfect. I get a 0. This means that 2 is a 0 of this polynomial because whenever I actually divided by my 2, my remainder is 0. And so this also means that x minus 2 is a factor. That's good news. That's what I want. Once you get to here, you can pretty much go ahead and finish the problem. Let's look to see what we got whenever we did our division. What was our quotient? So I have this right here. That's what I'm looking at. I know that my 1, that's like in the column of my x cubed. So what you do is you go down a degree. And then I have a 0. That would be my x, but you're not going to do plus 0x for your actual answer. If you needed to plug in missing terms, yes. But for your answer, no, we don't do that. And so the next thing I have is a -25. That would have come from the 25x right here value. And because I'm going down a degree, it would actually go to a constant. It would go from an x to the first power to a constant. So this is what I get. That's my quotient when I synthetically divide by 2. Because I found that 2 is a factor, x minus 2 is a factor because 2 is a 0, this is how I write this, okay? I put my quotient into parentheses. and I put my x minus 2 next to it. Now, once I've gotten here, I can very easily figure out what my other zeros are. Of course, to find my zeros, I have it set equal to 0. And then now let me see. Y'all, I actually notice that what I'm looking at is a difference of squares, meaning that that binomial right there can be written like this. I already know. Okay, so for C, it tells me to find all zeros for my C. And you'll actually enter them like this. I already know that 2 is a 0, right? I'm trying to find the other zeros. That's why I'm factoring like this, y'all, because I need to find all the zeros. So if I actually set all of these equal to 0, this one would give me 2. This would be x equals 5, so that's a 0. And then this one would be x equals negative 5, so that's a 0. So technically, if I'd kept going through this line and being like, that didn't work, okay, that worked. If I didn't do this step right here, I would have then plugged in negative 2. And I would have learned that my remainder would not be 0. And then I would have done 10. And like I would have just continued to find out that those would not work for my zeros. And I know that here I got a 5 and negative 5, and these values don't even have 5 listed. And that is because of the form of your other factor. When you do your synthetic division, there's going to need to be more factoring done, and then it does break down into your actual zeros. Trying to think of what else. List all possible rational zeros. You need to know your factors to do that. Actually evaluate the fractions. I don't know if in the homework it'll tell you your first zero. I know that in an exam, it won't say your first, 0 is negative 2. You will need to plug in a couple of them to figure that out in order to solve for all of your zeros. Once you find an actual 0, you're going to use your quotient that you got when you did the synthetic division, and you'll set the factor that you just learned was a 0 and your quotient, and then you'll just kind of see what other factoring needs to happen. Okay, I guess that's really it for this example. I will do one more video. I think maybe 2 more should take care of this section. If y'all have any questions, make sure y'all ask, okay? Thanks. Bye.